Hello all. In this video, we are going to see stack operation, stack data structures. Okay, so I posted two short videos before the stack operation. One two short animated video I posted in my channel. Okay, so I will attach that particular link in this video description. Okay, so you just going to refer that particular video first so you can understand the overall operation of the stack. Okay, so stack is nothing but it will be a uh, first in, last in, first out operation. It is like a bucket like structure data storage in which whatever the particular we are having the data we are going to store and we are getting into the particular we can get in the recent data. For example, I will go to call log here. If you are see the call logs, so any kind of call logs you have seen that. Okay, so recent call logs are always getting into the first. Okay, so this is like a stack like structure. That means from the recent data to the last data, I can able to organize my data to my view purpose. This particular data organization we can call it as stack. In short, we can call it as last in, first out. That means the last call is had by one person by 9:15 a.m. That will be the first here. Likewise, stack will be arranged. So technically, we have seen the picture like this. So initially, we are having that particular top pointer is -1. So I assumed my stack is empty here. Okay, so when the top pointer is -1, I will assume as particular stack is empty. Why? Because if I go to the next thing, you will see the difference. Now is incremented as 0. That means I am inserting one element into the 65 element into the. So there are two operations in the stack. One will be the push, another one will be the pop. Push means inserting the element. Now current top element will be 65. So when I'm going to push another element, my top element will be increased. So my another push operation is performed here. So my current top element is 98 at the index 1. So my top element is 1. So I want to delete the element means current top pointer will be deleted. Then here my some mistake is there, top will be 0 here. Okay, the top will be here, it will be 0 here, and my particular top will be decremented. My current position will be 65. Always pop will delete the top element. For example, pop is going to deleting the 98 here, and it will going to decrement to the 0th index. So pop operation means deleting the top element and push operation means inserting the element. So I can increment my top pointer then and there. So what are all the status we have observed here is, first of all, top is equal to -1 means my stack is empty. That means there is no element in the stack. And another thing is here I can able to handle 0, 1, 2, 3, 4, 5. So totally I can able to handle 5 element in this particular stack structures. If I going to insert the sixth element in this particular stack, automatically stack will be overflow. Okay, stack will be in the overflow. Okay, so I am just just summarizing my previous video animation here. Okay, if you couldn't able to understand my description here, please see that two animated short video before this video. Okay, then getting into this particular video, you will understand easier. So let me go to the program. So here in this program, we are going to see, I am going to implement the stack structure in the switch case. There are three operations I am going to perform. One will be push, pop, and third one will be display. Okay, so let me going to execute this first. Actually, it will be not n minus 1. It will be max size minus 1. Lesser than or equal to top. So something will be there. Okay. Okay. So now we are having three operation here. One will be push, another will be pop, and another will be display. So push in the sense it will going to insert the data in the stack. Pop in the sense it will be going to delete the topmost element in the stack, and display I am going to display the current element in the stack. So for an example, if I run this one, run here, so first of all push element I am going to give the choice number 1. So I enter the element to push 65. So 65 is push. So my current top element will be 65. So then I am pushing another element number 1, 98. Then I am pushing on one more element 56. So I want to display the element 3. So now you see that first element is 65 and next element is 98 and last element is 56. So the top pointer will be going to pointed with the 56. How I can show means, for example, I am going to press 2 only. I am not going to specific any index here. I am just going to give choice number 2 as pop. Automatically it will going to tell that 56 is going to pop from the stack. So how is it possible? Because as per the stack principle, topmost element will be going to be deleted and top pointer will going to decremented to the next element. That is the pop operations. Likewise, it will go into switch wait. So what is the main application of the stack means we have to arrange the recent data to the last updated data. So we are getting into the stack. So now I am having three particular uh, operation here. First will be the push operation. So the push operation means I am checking whether the max size minus 1. My top element will be the max size minus 1. So what is actually max size minus 1? Here I am defining my value of max size as 10. So throughout my stack size is 10 only. Whichever the function, whichever the choice of operation I am doing, I am defining my max size variable as 10. So here max size is minus 1. For example, here in this picture I am telling you, so 65 is my zeroth index, 98 is my first index, and second, third, fourth, fifth. Okay, so 0, 1, 2, 3, 4, 5. Totally 6 elements, and totally there are 0 to 5 index are there. 0, 1, 2, 3, 4, 5. So when my particular my push operation reaches the n minus 1, if I want to insert the another element, that means if I want to push another element here, automatically the stack will show it is overflow. That means I am not able to insert any data. Likewise, I am here, I am checking my data here, max size minus 1, because I am starting my array value from 0. Okay, so here I am going to give the information as stack overflow. Stack is full. Okay, or else I am going to, for example, if the stack is not full means there is some space in my stack. So I am getting the value from the user, and then I am going to increment, I am going to assign the particular stack of top will be, that means stack of top increment is equal to value. That means what is top plus plus here? So let me going to ensure that top plus plus, currently my top value will be minus 1. Okay, so in the same picture, I am telling that when the stack is empty, I am indicating my top value as minus 1. That means still I am not started my stack from 0th index also. So my top value is minus 1. So here I am initializing top as minus 1. That means I am having one empty stack. So here you just going to increment the one incremented the minus 1 here. What will happen here? My stack of 0. That means if the minus 1 is incremented, it will become 0, and I am going to store my first value. I am going to store my value in my first. So currently my top pointer will be indicated in the 0th index. Okay, so this is how we can insert the data into the stack, and how to ensure whether we can delete the element from the stack. For that also we need to check whether there is some element in the stack or not. Again I am going to using that whether my element, my top is double equal to minus 1. Just now we have inserted one value. So my top pointer will be in 0. So obviously my particular top is not equal to minus 1. If it is equal to minus 1, in some scenario my stack is underflow. That means when there is no element, I couldn't able to delete not even a single item in my stack, or else I am going to pop the element top pointer and it will be become top minus minus. So one thing, another clarifying thing means, why do we make a stack and of top minus minus? Because the my array variable I am indicating as a stack. My top is my pointer which will be located my recent data. That means topmost element in my stack. And how to display the element? For displaying purpose also we are mentioning the same condition. If top is double equal to minus 1, my stack is empty. That means there is nothing to display. Or else I am going to make from 0 to up to the top. So only you have to give lesser than or equal to top. Okay, why can't we give the max size here? Because currently, for example, if my max size is 10, okay, currently my max size is 10, but I am inserting 5 elements in my stack. So my top pointer in my fourth index. If I inserting 5 element in the stack, my array will be starting from 0. I am in my fourth element in the stack. So my top pointer will be 4. So from 0 to 4. That's why I am giving lesser than or equal to. That means up to the top I need to print from 0. Okay, so I am going to print all the element in the stack. Okay, so for final purpose, I am going to give the exiting the program default as invalid choice, and I am going to ending my while loop. This is how my particular stack works. Okay, stack data structures works. Thank you.